Okay, so welcome to the third installment of the Digital Humanities After Hours series. The speaker today is Arnoud Wils from Maastricht University. He's going to be talking about how to turn PDFs into interactive resources. We're very happy to have him as part of our seminar. I actually first heard him talking at the DARIA annual event this year, and I thought that's a brilliant talk, so would very much love to have him as part of our seminar. So welcome, and please go ahead.
Thank you, Elena, for your kind introduction and for having me at your DH After Hours series today. I'm currently talking from a few thousand kilometers away. I'm sitting in the eastern side of Belgium, and as you see from this first slide, I currently hold a position at Maastricht University, the Faculty of Arts and Social Sciences, at the plant, and the plant is our digital lab, where we offer first a space where researchers and students can explore digital equipment ranging from 3D printing over audio and video recording equipment, including a podcast studio, to VR headsets as well. But apart from that, we offer also research software support. So our mission is not to provide IT support, but really to have our researchers get their feet wet with some coding, some research software, some AI. We organize trainings, workshops, prepare some coding notebooks, just to learn them or to give them the skills to discover themselves how to use research software and what could be the potential of AI for their own projects. My official job title is Research Software Engineer, but I'm not a typical IT person, I should say. I graduated in classics and I have a PhD in literary studies at Leuven University, where I worked a large part of my career. And I've also always worked at the intersection of IT and literature, culture, and media, so to say. Just maybe one remark before we start. Don't hesitate to interrupt me for asking questions, because it feels always a bit awkward to do an online presentation, because you're talking to the void, you're not seeing the audience. So don't be afraid to let me know that you're still there by intervening or by asking more questions. Okay, our focus today is on the Corpus Rubenianum, which is a catalogue of works by the famous Flemish painter of the 17th century, Peter Paul Rubens. It's a catalogue which charts more than 10,000 artworks in about 40 volumes. The catalogue contains text, explanations, images about almost every work that came into being under Rubens' supervision, and also high quality copies of his works that were produced by his assistants or pupils or successors are covered in the catalogue. The Centrum Rubenianum in Antwerp coordinates the publication of this catalogue of the corpus. The first volume was published in 1968, and work is still ongoing, and it's the expectation that the last volumes will be issued over in 2 or 3 years or so. The Corpus Rubenianum is hosted in the Rubenshuis Antwerp, where Rubens himself also lived and worked. The painter bought the house and renovated and extended it, and you see it has almost it looks almost like an Italian palazzo from the outside. It's currently closed for renovation, but the gardens had been renovated last year, and they're really gorgeous, as you can see on this picture. The Rubenshuis also hosts an experience center where you can interactively engage with the works of Rubens, as you can see on this image. And there is also a library and a research center as well. The corpus, and that's an important information also, the Corpus Rubenianum is based, this catalog is based on the documentation by the Rubens expert, Rubens specialist Ludwig Burckhardt, which was a German art historian. Already in 1917, he made a dissertation on the etchings by Rembrandt. Then he moved to Berlin, where in the 20s he worked as an editor at the Zeitschrift für Bildende Kunst. And he wrote his first, or he completed a volume on Rubens in the 20s as part of the series Klassiker der Kunst. And then in that time already he had the first idea of making, he envisioned a new catalog raisonné of the works of Rubens. Of course, the 30s, 1930s meant some troubles for him, as his mother was Jewish, and the family and he himself moved to London, where he settled outside the city with his archive of Rubens material. And then in 1939, he already published the first prospectus of what should become his catalog, prospected for about 6 volumes. After the Second World War, many paintings by Rubens appeared on the market. Others had to be restored, re-examined and cleaned. And that meant again some delay for his catalog project, of course. In 1956, to celebrate Burckhardt's 75th birthday, the Rubens has organized an exhibition on the drawings of Rubens, and Burckhardt wrote also the catalog of this exhibition, which still is considered as one of the most important books on that topic. In 1960, Ludwig Burckhardt died, and the city of Antwerp acquired his archives, and together with the Center for the Study of Flemish Art in the 16th and 17th century, which is now called the Centrum Rubenianum, they agreed with the heirs of Burckhardt to edit and to complete this work, the edition and the publication of the catalog, using the extensive documentation collected by Ludwig Burckhardt. He himself so never managed to publish the catalog himself during his lifetime. So the corpus contains 40 volumes, and each volume deals with a specific topic, and for each volume a researcher with specific passion or specific interest in the subject, in the topic, was sought, so that he or she could enrich the subject with his or her own expertise. So what is, or what was, the challenge? The challenge is this. Namely, you have really a treasure trove of high quality scholarship locked into 40 volumes on paper. I must say that books that are more than 15 years old are available as searchable and browsable PDF documents. But still, you have a plain running text with a lot of information in it, which well, is hard to use for research purposes. So the challenge was, well, how can we get this information in a more structured way? And I give you here an idea of how this catalog is looking. You see, this is a PDF document where each work one by one is described. It starts with a title, the type of the work. This is a tapestry, the size, and then a very detailed description of the scene which is depicted, with some footnotes, with some provenances. Provenances meaning a list of persons or institutions that owned the work of art or held the work of art in possession during a specific time frame. The copies that are made from that artwork, the exhibitions, literary references, etc. So you see a very it's very a volume and a catalog which is really with a lot of detailed information, of scholarly detailed information. And well, the challenge is, of course, how can we make this information available for researchers? How can we extract structured information from these plain running PDF texts? The challenge was put forward earlier this year in February at the AI for Culture hackathon. AI for Culture, as you may know, is a project that ran from 2023 to 2025, funded by the European Union. They have also a very useful platform, still online, aiforculture.eu, where you can find a lot of tools, data sets, and also tutorials on AI, on how to use AI for cultural heritage projects. And it ranges from natural language processing, machine learning, computer vision, handwritten text recognition, OCR as well. So it's really worth having a look at it if you didn't know of this platform before. So AI for Culture, they organized a hackathon at the end of their project. And one of the challenges, or one of the partners of the hackathon, was the Rubens House in Antwerp. And they formulated the challenge. Well, we wanted someone to try to see if we could extract structured information from our Rubens catalog. And I took on the challenge, and that was my contribution for the hackathon. And well, in this talk, I'm going to present you what I did so far and what are the first results. So the corpus, I focused not on the whole, the entire catalog, of course, but just on one volume, the Achilles series, which is a volume describing 8 tapestries, representing 8 episodes from the life of the Greek hero Achilles, from his youth to his death, dated between 1630 and 1635. And it includes descriptions of the tapestries and also related works of art. Oil sketches and modelli. I'm going to explain to you what these are. Here you see the first tapestry in the series at the right-hand side, depicting Thetis holding Achilles in the sticks, dipping Achilles in the sticks. As you may know, Thetis is the Greek goddess of the sea, and Achilles is the son of Thetis and the human king Peleus of Thessaly in Greece. And Thetis learned from an oracle that her son would die in the flower of his youth by someone who was less stronger than he. And she wanted, of course, to ward off this fate, went to the underground river, the Styx, to dip Achilles in the Styx to make him invulnerable in every part of his body except the sole of his feet, which she held while dipping him into the Styx. So this is the first tapestry. And you see the different stages of making a tapestry. You see also an oil sketch, which is more or less the first preliminary drawing of the design. Then you have the modello, and then finally you have the tapestry. Here you see another scene. Paris or Achilles discovered among the daughters of Lycomedes is the second scene of the series, where Thetis she foresaw that the abduction of Helen by Paris would lead to the war of Troy, and that her son Achilles might be killed in it. So she disguised her son Achilles in girl's clothes, brought her to Lycomedes to serve the king among the daughters of Lycomedes. But of course, the Greek hero Ulysses, very smart as he is, used a trick to recognize Achilles and to persuade him to follow him to the war. So that's depicted in this scene. As you see here, and this is more clear, there are different stages in creating a tapestry. You have the tapestry, the final tapestry on the right, but it starts with an oil sketch, and that's what Rubens first did. He sketched the outlines of the scene first in pencil, in black graphite. Then he painted this first sketch with preliminary outlines, bold outlines, using a broad brush in brown, and then finally added some more details using a finer brush and some more colors. Adding some details in hand, feet, costumes, and background. And these oil sketches were really very exquisite fine artworks on their own. They're about 40 centimeters width and height, and they serve just as a first design of the tapestries. Next stage were then the modelli. A modello is a fair copy of the oil sketch on a larger frame, on a larger canvas, probably executed by his assistants. Saved Rubens also some effort, some time. His assistant just transferred the design onto the modello, and then Rubens himself retouched it, corrected it, and added some more details if needed, or repainted if that was needed. Third stage was then the cartoon. Cartoons were drawings on paper in watercolor and black chalk, where the design was just transferred on paper. Unfortunately, not one cartoon in this series is preserved, and I will come back to this later. But this was also one of the stages in creating tapestries. I have also to say that these series, this biographical series depicting all the episodes in the life of Achilles, was rather unusual, and no artist before Rubens ever had illustrated the life of Achilles from his early youth through his death. Most artists just were limited themselves to just choosing one episode, and it is very likely that Rubens himself got inspired by descriptions of the life of Achilles in contemporary encyclopedias and dictionaries. You've also to take into account the specific context of tapestry weaving in that time. Tapestries provide the opportunity to create sequences of events, of representations of events, to decorate large spaces like public buildings or palaces. And in that time, quite a few vitae or biographical tales from mythological or biblical or historical personages or characters were translated, were formulated into independent stories that inspired this kind of sets of tapestries. So the catalog, our volume, which I've worked with, was describing 8 tapestries and the related works of art. So the oil sketches, the modellos, and the cartoons as well. What is the process? So the challenge was, well, we have this running PDF text. What are we going to do with it? We want to extract information from these documents. So what I first asked AI or leveraged AI to do is to find a structure in the documents and to try to identify subsections in documents and to bring some structure in it and to insert appropriate headings. It becomes clear in the next slide what I mean with that. I used to do that, I used a large language model from Llama, which was released by Meta. to bring or to discover the structure in the document, this parser, this llama model, not only takes into account the running text, but also the layout of the page. And I gave it I don't know if you see my cursor, my green cursor, I gave the model a kind of prompt saying, well, you're parsing, you're reading a catalog, and I want this catalog is structured, and I want you to identify subsections and to insert headings. That was the first stage. This is our PDF document, and this is what the model produced. So you see these number signs here indicating some headings. So the document now has already some structure. I have a plain text, and the model is able to discover different sections in the catalog. And this is important because in the next step, I want to dig a bit deeper, and for each section, I want to extract detailed information. This technical information is not that important. If you have a look at this slide, it makes it clear. I want to impose a schema, a template on the PDF document, and I want the AI model to force the data into a schema and to transform this running text into a list of artworks with an isolated title, with a type, a list of provenances, a list of copies, a list of literature, the characters depicted. So I leverage AI to extract bits and pieces of information in a structured way. It becomes clear in the next slide what I mean by that. So this is how it looks like behind the scenes, so to speak. So I asked the model to produce an art item, and for each artwork, I want the model to extract a title, a type, provenances, and copies. Let me show you how this works. So I give it a prompt, and I say, well, extract this structured information. You are an expert in analyzing art catalogs. I gave you a schema, and I gave you the catalog, and I want you to extract the required data in structured format. How does this look like? So this is our catalog, and you remember this from previous slides, where it starts with the title, and at the end here you see tapestry, which is the type of the work of art. And when we run our AI model, it produces this kind of output. You see the different bits and pieces of information here are rendered or are just isolated and are presented in a more structured way. You see very clear the title, the type, tapestry, which is here at the end of this line. And all other pieces of information are isolated and are presented. If you're not so familiar with the JSON format, just have a look at this slide. You can just compare it as, well, like a table-like format of information. And you extract the information from the PDF document in a way that could be represented, that could be displayed in a table, an Excel sheet, or whatever, just structured information instead of this plain text. A few other examples here. You have this copies section, and the copies being made from a work of art, which is just plain text, very difficult to see the different copies because it's just running text. If we ask the model, well, I want you to extract a structured list of this copy information, it gave me this. So you see the first entry, the first copy is just a painting, Philadelphia, and it clearly is able to isolate the location and the details. So this is how it works. It extracts from the running plain PDF text structured information using a template which I try to impose on the data. Here you have provenances. You see that Daniel Fourmont was the first one to own this work of art. There is also a date and there is also location. If we ask the model, well, I want you to extract these bits of information in a structured way, you get this output. So you see, I have now a very well-structured list of provenances with year, with the name in the place. And as you might already assume here, this could be very useful for research, for plotting these provenances on a timeline, for instance, or plotting these provenances on a map to visualize the information, which is almost impossible to immediately understand when you look at this running PDF document. Also interesting is that the catalog, of course, contains a detailed description of the different characters depicted on the painting, like Titus, like Lachesis, like him, which is Achilles. And I asked the model, well, just make me a list of all the characters from this description and add one line describing the character and the way how it is depicted on the painting or on the model. And the AI model is very well able to extract all this information in a structured way. I have a full list of characters with a brief description. And then finally, literature section. You see every work of art. At the end, there is in the catalog a literature section with some references, brief references, and pages and references to pages where the work of art has been discussed. At the beginning of the catalog, there is this full bibliographical list. This is, for instance, this type of literary reference. You see it, Burckhardt 1930, pages 13 to 15. And you see at the very beginning of the catalog, there is a literature section where you see the full bibliographical record. And I asked the AI model, well, try
we can no longer hear you. No, still nothing. Nothing.
My audio still.
Now it's fine.
It's fine.
Okay. Probably my internet connection was a bit unstable. So you see at the beginning of this catalog, you have these full bibliographical references. In the catalog itself, you have these abbreviated literary references. And I asked the model, well, could you resolve these very brief references with the full bibliographical references? And the model did this very well. As you see here, for instance, I have this very brief reference. The model was looking up the full reference at the beginning of the catalog and displays this here in a structured format. Okay, that's maybe all good and well and interesting to do, but why could this be useful? What's next? Well, we could use this structured information to get some insights and to trigger some research questions. Let me give a few examples. First of all, you can use these structured data to enrich existing data. As we saw already, the model was very well able to resolve bibliographical references. And the Centrum Rubenianum is collaborating with the Center for Art History in the Netherlands. They hold a database with the digitized copies of the works by Rubens. And their online catalogs has also a literature section. And if you have a look, you see that those references are all very recent. And it would be, of course, nice if we could enrich, if we could complete these bibliographical entries with all the references in the catalog by Burckhardt. And we can do that because we have this information available in a structured format, as I explained I showed you before. Another thing what could be interesting is to have a look at those provenances. And we have dates, we have names, we have locations. Let's try to see if we can make a timeline, if we can plot them on a timeline. And this looks like this, for instance. This is a timeline using the structured data extracted from the catalog. And you see here this very hard, the beginning of everything, which is 1635. Daniel Fourmont was the first owner of the oil sketches and also the tapestries and the modelli, because he was a tapestry merchant. What you also immediately see is that the cartoon line here, there is a cut-off here. There is no cartoon after 1671, which triggers also, or might also trigger a research question. Why is this? Well, it appears that these cartoons were lost at sea. They were sent to Spain by the governor of the Netherlands by the time. And after 1671, no tapestry set has been woven. So it's very likely that these cartoons after that date were lost and forever, and no sets could be made afterwards. These are just very quick insights that you can have by just plotting structured data on a timeline. Another thing which might be interesting is to use these provenance data to create a network graph. You see the blue dots are the persons. You see the big name of Daniel Fourmont. And Daniel Fourmont was not only the first owner of these artworks of the Achilles series, but he was also the father-in-law of Rubens. This Peter Fourmont was the son of Daniel Fourmont. He also inherited from his father all the works of art from the series. Gerard van der Strecken was a very famous weaver at that time. Another interesting fact maybe is if you click on Daniel Fourmont, you will see that he's connected to light blue, dark blue, and red dots. The red dots are the oil sketches. And the blue dots are the modellos. And the light blue dots are the cartoons. So it's remarkable that a tapestry merchant, a tapestry dealer, also owns the oil sketches, because oil sketches were just preliminary designs which served for which were the examples. They served for his assistants to give an example of how the cartoon should be made. And normally, tapestry dealers don't need these oil sketches, these preliminary sketches. The fact that all these sketches were owned by Daniel Fourmont is a very strong argument in favor of the statement that probably the set, the Achilles series, had been designed for Daniel Fourmont, father-in-law of Rubens, because he owned also the oil sketches, which were of no use for his business as a tapestry dealer, but of course belonged to his personal precious personal belongings. There is in 35 there is an inventory made from Daniel Fourmont's estate, and the location of these oil sketches was in one of his private rooms. So not in his warehouse or in his shop, but in a private room where he held some personal belongings like other paintings or furniture. So the fact that Daniel Fourmont was also the owner of the oil sketches proves that probably Rubens designed the set for Daniel himself. And just then to conclude a last example, I told you already about the description of the different mythological characters in the catalog, and I asked the AI model to extract these characters and to give a short description describing how these characters are depicted on the painting. So, and I thought, well, it could be useful. Let's try to see how far we get with a computer vision model. I used a computer vision model, and my aim was to feed the model with the name of the character and the description, and to ask the model to try to recognize this mythological character on the painting. So the input was, for instance, the watchdog of the underworld depicted on the painting, and I asked the model, could you recognize this character on the painting? And the model had to answer with the coordinates of the bounding box of the detected object, meaning the coordinates of top left and bottom right pixels in the picture. And that was exactly what happened. I used for this a grinding dyno model, which is an open set detector, meaning you can just feed a model with a description, with a word or some word, and then it tries to recognize it on a picture or a painting. So I asked the model, try to detect Titi's holding her son by the heel, and that was the description I extracted from the PDF. And the model gave me these coordinates, and if you have these bounding box coordinates, you can of course visualize them on the picture. So this model was perfectly able to recognize Titis holding her son by the heel. Another example is the watchdog of the underworld. Tried to recognize this dog on the painting, and the model again replied correctly with the coordinates of the bounding box. Why is this important, or could be this interesting? Well, you could think of using this information to make image maps where like in a digital catalog, where the user could just hover a painting to make visible a layer with the description of the character, which is visible, without having to have a look at the catalog itself. Or you could go even a step further and to create an AR application where visitors in a museum could scan a painting on the wall, and then this AR application would show them in overlay a description of the characters displayed on the painting, which is very well possible to do. I'm currently investigating this and working at a prototype, and also got inspired by work done at the University of Amsterdam, where they have trained this model with specific descriptions of artworks, which makes the model more precise, of course. Okay, this was my talk. Next steps is, of course, and I now focused on just one volume. It would be nice if we could just proceed and do the full parsing of the full corpus, and to get all data out of the corpus. Of course, data valorization options could be refined, could be improved. We could set a few next steps in geomapping or creating timelines of network graphs. And then, especially for the object detection, I think there are some next steps to do and to work out a real AR application. That would, of course, be great. Currently, the partners in the projects are the Rubens House in Antwerp, the Digital Humanities section at Leuven University, and a private consultant partner, Datewell, also based in Antwerp. So I hope in this 45 minutes to have given you an overview of what could be done. Well, very briefly, of course, with just dusty, plain running PDFs to get some structured data out of it. And I thank you for listening. And please don't hesitate to reach out if you want to more information, or just to have a chat, or to see for more opportunities for collaboration or whatever. You can also find my slides on Zenodo if you want to have a second look.
Thank you very much. Are there, yes, question from Erikur.
Yeah, can you hear
Can you
me?
hear him?
Can you hear me, Arnoud?
Yes, I can hear you.
Yeah, it's really fascinating. What you describe is you describe it as if it's a kind of an easy process, but I guess it was complicated and difficult. So what kind of issues were you faced with on the way? I'm sure it's not just a question of asking the AI, but
Well, it might seem complicated, but I must say for the AI, for the hackathon where I created this world, we had only a few days. So it had to be done in almost 4 days or so. And I was also working at the university, so I didn't even have 4 days. So, well, most of the work was, of course, the testing. I knew, of course, what type of models to use. What I firstly did, and I think that what the first intuition was, well, I will just use a model and just to write a prompt and to ask, well, can you just extract me this and that information? And to ask a ChatGPT-like model to do that. But this didn't absolutely work well. So this was just giving me too much information, not good, structured very well. Then I proceeded to use well, there are many PDF extractors which promise you to be able to recognize text from PDFs and to give this in a structured format, but that didn't work either. So I really had to combine two things, and this pydantic templating and then the regular prompting. So those two together, imposing, creating, or defining templates in combination with prompts, was the best way to proceed to force really the data into the mold of the template and to get these data well structured out of the PDFs. But once you have the procedure set up, it works really well, and then you would be able, of course, to parse large volumes. It helps, of course, also that this catalog had a well-defined structure. So all the volumes in this series were had the same, more or less the same structure. They started with description. They had a provenance section, a copy section, exhibition section. So these sections were present in all volumes. So that helps a lot, of course. But it's, well, in AI, it remains, of course, a journey. I mean, every day models get improved, new models are launched. So this is an ever evolving story or evolving discovery, I should say.
Yeah, thanks a lot for the talk. My name is Jónas Sigtryggsson. I'm at the Árni Magnússon Institute in Reykjavík. I'm just wondering about if you look back a couple of years in time, when is the earliest that you could have done this with the advances in AI? Do you think?
What is your question exactly? How early is?
So there, as you say, there have been a lot of advances in the AI.
Yes.
How long ago could you have done this project with the same? For example, the Llama.
Oh, no, well, this is only launched this year, so this is a very recent. So Llama, of course, exists already 3 years or so, but the Llama extract, which is a Llama model really used to extract structured information, is really launched this year, and over the past months, this has really improved a lot.
Yeah. Okay. but it can be sometimes difficult to get a sense of where you are in the timeline.
No, it's well, it's something, and Llama every few weeks they have an update of their model. So for me, it's still a challenge to keep track of all those developments, and also to try the models and to see what's their potential. That's very well true.
Yeah, exactly. Thank you. Just one more question, a short one. The graph that you showed on
the network graph.
Yeah. How did you do that? Is that
That's made by Sigma. That's also a library, but it's not so complicated. So you can. I made this. This is in an HTML Sigma library with the advantage that it's clickable and that you can use it on a website. You can also use this in just plain Python code or so, but I decided to use it just the web version, which I just used it out of the box. So I didn't fine tune it myself. Of course, you need some structured data. I had, of course, the names. I had the types of the different paintings. I had some the dates, of course. So you need all this kind of structured information, but then it was quickly done to project this kind of graph.
Yeah, it looks good.
Yeah, it looks very well. It's a very nice library. Yeah, indeed.
Thank you.
Yes.
Okay. Can I ask you about the hackathon? Because I'm kind of interested in this, that as a concept and a process. So how was it organized? Who participated? What kind of groups did you get together?
Well, the hackathon was organized in February at the University of Leuven. So currently, the AR for Culture platform is maintained by the National Technical University of Athens, which also delegates, of course. We had a week, I think, just 1 week. It started with a launch. The first day, the different partners just explained or presented their data sets, and one of the data sets was the Corpus Rubenianum from the Rubens house, but there were also other partners as well, like Europeana, for instance. So they presented their data sets and they presented their challenge. Then in the afternoon, we got a few hours to try to come up with a good research question and to fine-tune the challenge and to make a selection, of course. And then over the next 4 days, we had to work together and to try to take on the challenge, because results had to be presented then at the final day, also at the University of Leuven. So we had only a few days to really work through it. And of course, the partners like the Rubens, they were available during the hackathon online. Were they available to answer questions or to provide some more materials? But it worked really well, and I find it very rewarding to participate.
But how were the groups composed? So you had what kind of people were?
Well, mostly, I must say, mostly they were just students, or mostly they were students. I must say, I was a bit an exception, but yeah, mostly student groups, and also not always really developers. Of course, it was not for developers only. The most successful groups were just a mixture of more technically people and people who were more familiar with the contents of the challenge, of the data set, I must say. But it were mostly, if not all, student groups.
There are 2 more questions, one from me and one from
Alert.
Yes.
Hi. Yeah, my name is Alert Johansson. I'm also working here at the Arnoud Institute. I noticed that in your data, a lot like you said, has some structure already, like the provenance and how the catalog is organized. But I was wondering, in the part that's just a description of the artwork, were you able to tease some structure out of that part, the description of the artwork? I see there are some names there. There might be some description of nature settings or somehow how the painting is organized. Is there some sort of a systematic way to extract that kind of information out of the data you have?
So apart from the more structured sections like copies and provenances and exhibitions, you have this detailed description of the artwork where I managed to extract a list of characters displayed on the painting with a short description. So that works very well also with a large language model. So if you have a plain text describing something, you can ask the model to extract information or to display or to rephrase information in a more structured way. So I think this this description of the artwork, describing the scene and the different characters depicted, is just plain running text. And yeah, it was really remarkable how good the model was in extracting the names of the mythological figures and their description. Of course, you could have also asked something else, like describe me in one sentence the setting or so. Or you could try ask them all to classify, for instance, the settings in, well, 3 or 4 categories, you know, for instance. So that are all different things you can do.
Can you maybe mark them up with like labels like Greek mythology or something, some themes like that, so you could...
Yes, of course. And then you're maybe touching on what's called named entity recognition. You could also ask the model to recognize geographical or proper names in the catalog, and even maybe add a label if this is from Greek mythology or other mythology, or if this is a historical figure or a mythological figure. And that are all things you can perfectly do with large language models.
And that kind of information would also be interested to look at in the network graph.
Of course, yes, and then you could display these. Yes, of course, yeah, that could be very useful as well.
All right, thank you.
My question was very similar, so I was wondering about the applicability of your pipeline to PDFs that are less structured than ones that you use. So PDFs that do not have very clear headings like the ones that you were using. What kind of additional steps and components would you add to make sense of those?
Yes, of course, you need to know before what kind of information you want to extract. Probably you know the content of your PDF, you know that types of information are present in it. So you could think of designing, creating a template yourself, that you say, well, I have a plain text without any headings or whatever, but I know these types of information might be in it. And that's also what I did. I created this schema, but I also added to my prompt, if you cannot find an example of this type of information, please don't add it, or please put an A or something like that. So if you have in mind your template, it's perfectly possible to extract this type of information from, well, a full text PDF without any headings.
Thank you. Any more questions? No, but I just wanted to say this was a brilliant talk. Very, very interesting work. So thank you very much. Thank you.
And yeah, well, you have my email address, so don't hesitate to reach out if you want to, if you have further questions or want to collaborate or whatever.
Thank you.
Thanks a lot.
Okay, thank you.
Thank you. Bye.